Okay, in this video, I would like to go over the last three problems from our notes. These are all weight-based dosage calculations that require very careful reading and precision when it comes to working with the units. And so in this particular problem that we're starting with, there's a lot going on here. And when I look down below, I want to just focus on what I'm asked to find first. So we are working with a patient who is 27.5 pounds. And what we need to know is how many milligrams is this individual going to require for their loading dose, and then how many milliliters are we going to administer. So we need to think about how much our 27.5 pound individual needs to receive. So looking up top here, it looks like we're given a whole lot of information. We're given a table where the amount of medication and the form in which they need to receive it is based on their body weight. So we have to figure out which group do they fall into. Do they fall into this first row of 3.5 to 40 kilograms, or do they fall into the second row of 40 kilograms and higher? Once we know that, we'll be able to focus on the information like the dosage form, and then this is the information that we will be using to calculate how much medication they need. The loading dose is just a dose that's given to them on day one. So that's kind of like a first, when you think of this idea of loading, you're giving them this first dose. And the maintenance dose are follow-up doses. So this is going to be the next day from day 2 and on. And so it looks like if they fall into this first group, they're going to have a weight-based dose. If they weigh over 40 kilograms, they're just going to require 200 milligrams. So that's not weight-based. So let's figure out which row they fall into. And to do that, we're going to convert the 27.5 pounds. We're going to convert that into kilograms. And I know there are 2.2 pounds in 1 kilogram, so I'm using a little bit of dimensional analysis there. And I should get that this individual weighs 12.5 kilograms. So that means they fall into this first row, 12.5 kilograms. And that means we have to calculate the amount of medication they need for their loading dose based on their weight. So let's figure this out. We know they need 5 milligrams for every kilogram that they weigh. That's their loading dose. I know they have a weight of 12.5 kilograms. So I'm going to multiply by their weight. And when I multiply by their weight, the kilograms will cancel. So I'll have 12.5 times 5, which is 62.5. So they need 62.5 milligrams for their loading dose. Remember, milligrams, measure of mass. And this drug is going to be found in this powder. And so now what we have to think about is how many milliliters to prepare. So this is a powdered form. And what I notice in this problem is that I'm given reconstitution instructions. This powder will need to be dissolved in some sterile water. So what we'll do is we'll add 19 mLs of sterile water. We're going to shake that vial for 30 seconds. We're going to let it settle. And this is the key piece. The strength of the medication after it is reconstituted is 100 milligrams per 20 ml, which is equivalent to 5 milligrams per ml. So either one of those is okay to use. They are equivalent ratios. So I'm going to use the 5 milligrams per 1 ml. That's the strength of the medication. And that's what I need to use to convert milligrams into milliliters. So I'll go ahead and take my 62.5 milligrams, and I want to convert that into milliliters using the strength of the medication. So I'm going to write out my units. I know I need milligrams to cancel. I have 5 milligrams per 1 ml. And what we get is this should be 12.5 milliliters. This individual needs 62.5 milligrams of this medication based on their weight, which is equivalent to 12.5 milliliters once this medication is prepared. Okay, now I want to focus on the maintenance dose. So that is the second piece up here, 2.5 milligrams per kilogram. I need to figure out how many milligrams they need. This is all day 1, right? This first is day 1. Now this is day 2 and beyond. So now we're on the second day. We need to give the maintenance dose. How much do they need, and how many milliliters will we give? If you want to pause the video and try that on your own, go ahead and do so. I'm going to go ahead and start with my weight base uncustomized version. I know they need 2.5 milligrams for every kilogram. So I need to customize that for this individual. I need to multiply by their weight. So when I multiply by their weight, I'm going to have 2.5 times 12.5. And I get 31.25. So they need 31.25 milligrams, which is half of what they needed in day one. So that makes sense. They needed half of what they needed in day one. And so now that's how many milligrams they need. Let's turn that into milliliters. So I'm going to use the strength of the medication. I know there are 5 milligrams in 1 ml. So when I divide that by 5, we get 6.25 mLs. Now we have a rounding rule here. This is milliliters greater than 1, excuse me. So we go to the 10th place. They need 6.3 mLs. We didn't round the milligrams. We weren't told to round, and we weren't done with this calculation. So we're just going to keep it as 31.25, and that's what we used, the specific one, that specific value. So that means on day one, we would give them 12.5 milliliters. By giving them that, they would be getting 62.5 milligrams, which is based on their weight. Now, if this individual, if this pediatric patient weighed, let's say, 43 kilograms, then they would have fallen into the second row. And notice the maintenance dose and the loading dose are not weight-based. So we would not use their weight to calculate how much they need. This just goes to show that the math is no different, right? I know I mentioned this in class. The math is no different. Dimensional analysis, you could be using proportions here if you wanted to. You could use the nursing formula. We're doing conversions. The only difference is we have to sift through all of the information to pick out what's needed, and that is challenging. Let's go to this next problem. So we have this medication, carbamazepine. It's an oral solution, oral suspension, so that means I know it's a liquid. And the individual is ordered to receive 2.5 milligrams per day, and then that needs to be divided into 2 doses. And then we're given the medication label. And even before I get started here, I'm going to just pick out that the medication strength is 200 milligrams to 10 mLs. So that's what I'm going to use to convert between milligrams and milliliters. And I'm going to have to prepare milliliters because this is an oral suspension. Now, those are all just things that I'm going to bank in my mind. I don't know if I'm going to be asked about them right away. So let's see what's asked of us. Let's calculate the milligrams per day that this patient needs. So this is not involving the medication because I'm just focused on milligrams. The order is they need to receive 2.5 milligrams per kilogram per day. And so that per kilogram per day, we can write as 1 unit in the denominator, but we want to include that fraction bar in the denominator. There's actually 2 divisions here going on. We're dividing by the kilogram per day. And so what I need to do is to figure out how many milligrams per day. So to do that, I have to customize that value for this patient, meaning I need to multiply by their weight in kilograms. If I do that, then what I will be left with is the number of milligrams per day that this person needs. So let's go ahead and figure out how much they weigh. Let's figure out their weight. So I'm going to take the 70.4 pounds and I'm going to divide by 2.2 because I know there are 2.2 pounds in 1 kilogram. So 70.4 divided by 2.2, we get exactly 32. So I'm going to multiply by their weight of 32 kilograms. And when I take 2.5 times 32, we get 80. So we have a numerical value of 80, and the units remaining after I multiply by their weight, the kilograms canceled, this is the number of milligrams that they need per day. So over the entire day, that's how many milligrams they need. Now, I am told, and we're not going to give the medication, everything that they need, we're not going to give them all that medication, right? If I need to take 6 Tylenol throughout the day, I don't take all 6 Tylenol in the morning. That's not a good idea. So what we have to do is to divide this into the number of doses. And so we have to divide this into 2 doses. So the first thing I'm going to do is to show you how we can use dimensional analysis to represent this, and then I'll show you more of a shorthand way that's also okay. So what we have to do is to take 80 milligrams per day, and ultimately what we want to do is to convert the number of days into the number of doses. All right, we want day to cancel so that we have milligram per dose. And what I'm told is that 1 day will be divided into 2 doses. And so we have a dimensional analysis approach. This would be 40 milligrams per dose. So this is if we are using dimensional analysis. It is perfectly okay for you to use other methods. You do not have to use the perfect dimensional analysis in this situation. If you know that you're taking 80 milligrams per day and you're dividing into 2 doses, it's okay if you just say something like this: divide by 2 doses. Divided into 2 doses, you get 40 milligrams. But you want to continue to write that it's per dose. It's very important that you write either per dose or per day, because these are going to be crucial when we're looking at safe dosage range. So 80 milligrams throughout the day, we're dividing that into 2, or dividing that by 2, to get 40 milligrams. Each time they receive this medication, they need 40 milligrams. And now the final part is to figure out how much medication that is. So we want to figure out now, how much are we actually going to prepare? How much are we going to give them each time we give a dose? So I have to turn 40 milligrams into an equivalent number of milliliters. That's what I need to do with this calculation. And I can only do that using the strength of the medication provided. And so I know the strength of the medication is going to help me convert those milligrams into milliliters. There are 200 milligrams in 10 mLs. And so what I'll do here, you can use the nursing formula, you can use dimensional analysis. I'm going to take 40 times 10, divide that by 200, we should get 2. So they need to get 2 milliliters of this oral suspension twice a day. So how much are we physically going to give them? We're going to give them 2 milliliters each dose. All right, we have one more calculation. And in this calculation, we have a few different calculations to complete because we have a range. We are told that the common dosage range for this medication, clindamycin, is 10 to 30 milligrams per kilogram per day. And this could be divided either every 6 hours or every 8 hours. So if we're giving this medication every 6 hours, that would be 4 doses in a day. If we're giving the medication every 8 hours, that would be 3 doses. And I'm just getting that by dividing 24 hours by either 6 or 8. And so we have to be really careful here and make sure we're reading the order correctly, which one we're following. Are we ordered to give this over 4 doses or over 3 doses? So our client weighs 66 kilograms. And we have the available medication here. And I believe what would happen in this situation is that this would be drawn up and put into an IV bag or slowly infused is my yes for an intravenous use. And it is not for a rapid injection or push. So that means we'd prepare this in a syringe, we would put this, or the pharmacy would put this into a IV bag and then send that for an infusion. So let's figure out how much of this medication is actually needed for this patient. So suppose an order stated to give this medication every 6 hours. So I'm just going to write out that that would be 4 doses in a day. calculate the milligram per dose range that's needed for this patient. So this problem requires us to consider both the minimum and the maximum. So I'm going to write that over here. We have our minimum and our max. Our minimum is 10 milligrams per kilogram per day. And the max is 30 milligram per kilogram per day. What we need to do is to find the milligram per dose. So we have to convert each of these into milligram per dose. What I notice is that we have to customize this for this individual, meaning we have to multiply by their weight. So I'm going to just start with the minimum amount. Let's multiply by the weight, which would be 66 kilograms. And when I do that, kilograms cancels, and I'm left with 660, and the units remaining are milligrams per day. So I'm going to write milligrams per day. I'm going to make a little line here. And let's just do the same thing to the maximum. So let's go ahead and multiply by 66 kilograms. If you multiply the maximum value on that range, we're going to have the number of milligrams per day as the maximum. And so what we get, if we take, let me just put this in my calculator to make sure, 66 times 30, we get 1,980, and the units are milligrams per day. So that's how many they need per day. What we need to figure out is what they need per dose. And so what I need to do here is to divide by the number of doses. I have to think about, I'm taking this entire amount over the day, and I'm dividing this, excuse me, by 4 doses. So I'll just go ahead and divide this by 4 doses, and the reason it's 4 is because we're doing this every 6 hours. So 660 divided by 4 is 165. And this is the number of milligrams that they need as the minimum per dose. It is extremely important. Cannot emphasize this enough. We have to include our units in our dimensional analysis, in our answers. If you're not writing units, it is very possible or probable that you will get incorrect values. We have to keep track of, is this per day? Is this per dose? Is this milligrams? Is this milliliters? Very important to keep track of those units. So it's not just milligrams, but it's milligrams per dose. And I'm going to do the same thing to the max. I'm going to divide by 4 doses. So if you take 1,980 and you divide that by 4, you get 495. So 495 milligrams per dose. That means this individual who weighs 66 kilograms should receive somewhere between 165 milligrams per dose and 495 milligrams per dose. That's how much they need. We got this by multiplying by their weight. We considered both the minimum and the maximum, and then we divided by the number of doses. And so in this situation, we were dividing by 4 because we are giving this every 6 hours. There are some problems that might say, or some orders where you're giving this over 8 hours. So in that case, we would have divided by 3. The final thing to do is to calculate the number of milliliters per dose. So this is the number of milligrams that they need. 165 milligrams is our minimum. And then our max is 495. And this is the number of milligrams that they need per dose. And what we have to do is to figure out how many milliliters that would be. How many milliliters we'll be preparing and giving to them as part of this infusion. That has to come from the available medication. The strength of this medication has 12 milligrams per ml. You could use either one of these ratios, 600 milligrams to 50 mLs or 12 milligrams to 1 ml. Either one is correct because they are equivalent ratios. But I'm going to go ahead and use the one that's already simplified. There are 12 milligrams in each milliliter. And so I'm going to take my 165 milligrams and I'm going to divide that by 12. And we get 13.75. And this is milliliters. We round milliliters greater than 1 to the 10th place. So this would be about 13.8 milliliters per dose. And let's repeat that same process for the maximum. So I'm going to convert those milligrams into mLs. I know there are 12 milligrams in each ml. And so what I will get if I take 495 divided by 12, 41.25. And this is milliliter. So this would be 41.3 milliliter per dose. So that means, depending on what the prescriber orders, it should be somewhere between 13.8 milliliters and 41.3 milliliters per dose. That's what we are expecting for this individual who weighs 66 kilograms to receive.